This is a free response section for chapter 1 practice test, exploring data. So let's look at number 17. So those of who want to study for multiple choice questions for chapter 1, you can watch the other video. Make sure you pause the video before you actually watch it. And I want you to try first, okay? Number 17. During early part of 1994 baseball season, many fans and players noticed that number of home runs being hit seemed unusually large. Here is a dot plot, numerical summary for the number of home runs hit by American League and National League teams in the early part of 1994 season. Okay. So there's a dot plot about the data, and then they gave you here American League and National League. They have basically, you can see like 5 numbers here: minimum, first quartile, median, third quartile, max. Those are 5 numbers theory, and also they give you mean. Okay. And then this is a number of data, 14 each one. Now A, determine there are any outliers in the distribution. Show your work. So they checking you understand like how you're gonna determine some data is a outlier. Outlier means the data value is like away from the most data. Okay, but there's things you need to know to find out outlier. So let's talk about the American League first. American League. So the way you need to do is a 1.5 times interquartile range. Okay, so which is 1.5 times interquartile range means a quartile 3 minus quartile first quartile. So American League, so we talk about 68 minus 49. 68 minus 49. So once you put in the calculator, you get 2080.5. Okay, now so upper portion is basically that 68 third quartile plus that 1.5 times interquartile range, which is 28.5. Then you get 96.5, which means above any data above 96.5 will be outlier. Okay. So but if you look at here, maximum is a 77 in American League. So there's a no outlier in this case here. Okay. So none. Outlier. None for that portion. Now lower is from first quartile, which is a 49 minus 28.5. This time you subtract. Then you'll get 20.5. And then any value lower than 20.5. So if you look at here, lowest to minimum is 35. So there's a none, right? No outlier the other side too. So there's a none. What about National League? So also 1.5 times interquartile range is 1.5 times quartile, third quartile minus first quartile. So 55 minus 46. Then when you multiply it out, you get 13.5. Okay. Now, so upper portion, so same way. So you do third quartile for national is a 55 plus interquartile range is 13.5. So if you add up, then you get 68.5. So any value greater than 68.5 will be outlier. So if you look at the max is a 67, so there's a none also. No values is greater than 68.5. Now, let's move on to lower portion. Is basically 46 minus 13.5. Then you'll get 32.5. Okay, so any value lower than that is outlier. So I see the minimum 29 is lower than that. So definitely And if you look at this value right here, that's around like 29 and 31. Those are less than 32.5. So there's a two outliers, right? 31 and 29. Those two outliers. Okay, so those are how you're gonna find out the outlier. Now B, draw parallel box plot of this distribution, and be sure to label plots and provide the scale. This one, you need to draw two box plots. So in order to do that, you need to draw scale first. So let's say you draw scale here. It'll take time. So like 28, you can say 30 and 32. So you keep going. 34, 36, 34, 36, 38, 40, 42, 4, 46, 48, 50 here, 2, 4, 6, 8, 10, 60 here. Now you can do 6, 8, 10. So 70 here, then 2, 4, 6, 8, maybe up to 78. That's I think around there that will be enough because that's close to maximum. So when you draw first, let's do National League first. National League tells the 29 and 31. So I'm gonna mark it 29, and here another one is 31, right? So 29 is should be right in the middle. 29 and 31 here. And then so you're so I see that there's a value little over 40. So you can say like 40, that's 42, like around 42. So next one is around 42 right here. So I'm talking about right there, 42. And you're let's look at the 5 number. Then quartile 1 is National League is 46. So this is 42, 44, 46 right here. And then I'm gonna draw median 50.50. So that's 52, 54, 50, 55, 50 is somewhere here. Okay, and then quartile 3 is 55. Oh, 50.50, not 55. So 50.50, this is a 52. So 50.50 is a little less than that. Okay, a little less than 51. Now quartile 3 is a 55. This is 54 and 56. So right in the middle. So you can draw like this. Okay, you can connect it. So those are we call outlier. Okay, outlier. Now max is 67. So this one 62, 64, 66, 68. So 67 right here. That's the max. Okay. So that drawing is you can label here. This is a national. Now next one is American. So minimum is 35. So this one 34, 36. Minimum is 35 right here. Okay. And then you can do first quartile is a 49. So 49 right here. So 48, 49 right here. So somewhere here you can draw. And then median is a 57.5. So this one 58, 57.5 around here. Okay. Now quartile 3 is a 68. 68 right here. Okay, so you can draw. Yes. Now maximum 77, so around here. Okay. So this is a little crammed here, but it should be a little longer. This one should be a little longer. Okay. I run out of space, so it's more like evenly spread out. Okay. You have to notice. Okay, so this one is I'm gonna label this one is American League. Okay, And they say be sure to label and plot and provide scale. So that's basically what you have to do. Now C, write a few sentences comparing the home runs for each league. So you can say, first sentence I noticed, American League had a higher center, right? Higher center means this one, that median, higher than this, right? So you can say the American League had a higher center, right? We talk about median, so median. Said that 68. No, median is a 57.5 versus the other one is 50.5. Okay, so you can put more detail like that. Then National League, right? Then National League. Okay, league. Now, number 2, another one I noticed, you can say American League had a more variability than National League because when you talk about variability, which is interquartile range. So this interquartile range, right? And compared to this interquartile range, so American League is much wider. So you can say the American League had more variability, right? Because that one is an interquartile range. So you can say interquartile range for American League, basically here, Q3 minus Q1, so 68 minus 49, that one is a 19. And here, 55 minus 46, which is only 9. Okay, so you can say this one 19 versus 9. Okay, so more variability than National League. Okay, now third one you can write. We talk about center and basically variability, interquartile range, and also you can say which one is more symmetrical, right? So you can say the American League, this American League is more symmetrical. Okay. Remember that I kind of cram here. It's supposed to be longer, but so this shows more symmetrical. Then National League. Okay, so that's what you're gonna notice. It's more symmetrical. Okay, and then it had a more variability, and also American League has a higher center. Number 18, how much oil wells is in a given field will ultimately produce key information in deciding where to drill more wells. So here are estimated total amount of oil recovered from 38 data wells in the Devonian Richmond Dolomite area of the Michigan Basin in thousands of barrels. Now, the data is provided ascending order, okay? So they put in ascending order, so like that, okay? Ascending order. So maximum is like this, and then minimum is like that. Now, A, construct histogram for, so they checking, the other one we talk about here, box plot, right? And then now here they ask you to construct the histogram. So let's do that. So you can write the histogram. So maybe you can start with like 10, 0, 20, 30, 40, 50, 60, 70, 80, 90, 100, 3, 4, 5, 150, 60, 70, 80, 180, up to here. Let's put it up to here. Now, this one is a frequency. You can label it. Frequency, how often. And this one is, you can say, thousands of barrels of oil. So, thousands of barrels of oil. Okay, that's the X side. Now, so how you gonna graph it? So, between 0 and 10, only you have a 1. So you can say, let's see, frequency 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 2, 3, 4, 5. So, so only one data here. Okay, between 10 and 20, example, so you have like 3 data here. Okay, so 1, 2, 3, things like that. So if you continue, then you get this. Okay, so up to 20. And next one you have, if you count all of it, then that's total 8. Let's see. It's 8. That's a 30 to 40. 40 to 50, then you get 6. Okay. Now 60, 70, also 3. And the other 3. I want to spend time to read it there. So 60 and 70 and 80. 72, hold on. 50 to 60, whoops. 50 to 60 is also 6. And the other 2 is like that. Okay. Now you don't have any value between 82 all the way up to 150. But 150, so 160, you have a 1. Okay. So this looks like outlier. Okay. So that's the histogram. Now, based on your histogram, what numerical measures of center and spread would you be best to use for this distribution? Explain your choice. Okay. One thing I noticed this one is there's an outlier, and it looks like some slightly skew to the right, right? And this outlier. So if it's not symmetrical, then mean is not good. So should be median is a good center. Okay. If it's symmetrical, then mean will be good. But if it's skewed, then median should be good center. So you can say, since there is an outlier and some slight skewness, median, okay, not mean, median, and also spread is interquartile range. Interquartile range are the best measures of center and spread. Okay, spread. Interquartile range is good spread. Because it shows how much center 50% data located interquartile range, because they are resistant. Okay, so median and interquartile range, they are resistant to outliers and skewness. Okay, so those are good value to use, center and spread. Now let's move on to number 19. Now, does a party affiliation differ among genders? A review of voters' registration in the small town yielded the following table of the number of males and female registered for each party. So it shows male here, female, and those are party affiliation: Democrat, Republican, and other things like that. So, okay, A. Calculate the conditional distribution for party affiliation among each gender, and then present your result in the table. So you can say in the table by gender, male, okay, and female. So then each party, okay. So you can say Democrat and Republican or other. So I'm gonna write the conditional distribution. So that's a 300 out of 1,000, right, for the male. So Democrat is 300 out of 1,000. For Republican for male is a 500 over 1,000. Other is a 200. You can say in decimal here, so that's a 0.3, 0.5, and 0.2. Okay, so that add up to 100. So similarly, you can do female, which is a 600 over 1,000, 300 over 1,000, and 100 over 1,000. So into decimal, 0.6, 0.3, 0.1. Okay, that's the answer for A. Now B, discuss the relationship between gender and party affiliation in 2 or 3 sentences. Okay, so you can write this way. Obviously, for the male, the majority is a Republican, right, out of this. So for male, Republican is a majority. For female, is a Democrat is a majority. So you can say the males had the highest proportion of Republicans, while females had the highest proportion of Democrats, right? Okay, so you can write the value itself. So the Republican proportion for male was a 0.5 versus female Democrats of 0.6. So you can write the detail. Now, another sentence you can write is you can say the secondary party affiliation. The secondary party affiliation is they are basically same. So if you see here, this is secondary for each gender. So you can say they are even at 0.3. So those are both 0.3. So you can say Democrats for female, Democrats for female, and Republicans for male. Okay, so you can say they are same proportion. Now another sentence you can make based on the data we found over there. So now both genders had a party affiliation other as the lowest one. So you can say both genders had the party affiliation other as the lowest proportion. So you can look at it, the lowest proportion was a 0.2 and 0.1. So 0.20 males versus 0.10 females. Okay, so you can write that way. Okay, that's it for this video.